Welcome back to the Modern Ham, where we are connected in the old ways. In this video, I'm going to show you how to exploit a very popular BBS software to gain remote code execution on a Windows machine. So stay tuned. Alright, so I want to go ahead and start off by saying this is an educational video. The purpose of this is to bring awareness to a very real problem, as well as to educate people on services that they host and show them that just because one thing is intended to do a specific job doesn't mean that it can be used to access other things or be used maliciously. As we've seen in recent events for amateur radio, there's kind of a lack of security awareness, cybersecurity awareness in our field. And there's a lot of reasons for that. But my recent dive into packet radio has kind of brought a lot of issues to me that I've seen that made me worry a little bit. And it's kind of made me get my hands dirty in this whole situation. So let me back up and say this starts on April 25th. I sent an email out to John Wiseman, the creator of BPQ32, regarding a little buffer overflow that I found in the telnet part of the program that would basically just let people shut down the program. If you guys don't know, I do a lot of service hosting myself, and I'm also into like red team penetration testing. So when I host services on my computer, I test them and try to exploit them. That way, if I find a hole, I'm able to either patch it myself or submit a report to have somebody else who is the maintainer of that program to patch it. That is so that I can comfortably host that service for other people and know that there's not a bad actor out there that can exploit it and use it for bad purposes. So when I started to host BPQ32 for other people and show people about these packet nodes, I decided to try to exploit it myself internally to see if I would be able to use it to gain unauthorized access. John Wiseman actually acknowledged that there was a issue possibly maybe in the logging portion of this program, and said that there would be a patch submitted. Real quick, this is me from the future. I actually had to re-upload the video because I figured something out. This has been patched, but if you download the latest installer that's in the BPQ32, like latest installer for Windows, and disinstall it, you will have a vulnerable version of BPQ32. You must navigate to the beta, and I'll put the link on the screen and in the description. The beta folder under downloads, you will see a BPQ32 zip file. Let me just show you what that looks like real quick. This little file here, it is dated 2024-6/28. Download that zip file. Once you download it, you'll open it up, and you should see a BPQ32.dll file. Now, this is dated much later than the one that's installed with the installer. If you don't know, as long as you're on 64-bit Windows, which hopefully everybody is on 64-bit Windows in 2024, it should be in your C drive, Windows, syswow 64. If you are on 32-bit, it will be in your C Windows System 32 folder. You should have a BPQ32 file in there after it's installed, and you'll see that it's got the version 6.0.24.1, which is the version that is vulnerable. But if you take that downloaded zip file and you replace the one within your syswow 64 folder, you should be patched against the vulnerability we're going to talk about today. But it has been 4 or 5 months. I've responsibly disclosed it to the appropriate parties, and I've also warned the community in various ways that something is coming. So this isn't something I'm just dumping on people. I've done my due diligence to disclose this and also provide resources out there for people to secure their machines. What I'm about to show you basically allows any threat actor with access to an HTTP port or a telnet port of a running BPQ instance on Windows to leverage those ports to gain a shell into that system with no login. There's no, oh, this has to be Windows XP, none of that. This will work on the latest Windows 11 release, the latest installer of BPQ32, and it will allow basically anybody to control your radio or your computer. Once I figured this out, if you're into penetration testing, there's really no point where you discover a 0-day like this, where there could be a lot of people using a program and your heart doesn't sink a little knowing like what you've stumbled upon. And it takes almost everything in you to like not just try to tell people to, stop using the program, because you're afraid other people may have discovered this. Maybe they're just being quiet and using it to attack these users. So I've had to stay quiet for several months now, hoping that maybe this will get patched or remediated. But in the meantime, I have been publishing articles like what you see here. This is a write-up that I did a week or two after discovering these vulnerabilities, like how you can secure BPQ32. So I published this here, and I also went to the BPQ32 forum and published the same format with steps on, making secure tunnels for telnet and HTTP, and just general like security awareness, things that you should probably be doing anyways, that I recognize as a vulnerability within BPQ32 in one way or another. So I also wrote this blog up around the same time, talking about why this is a problem, and basically the lack of awareness going on between the users and also developers of amateur radio applications, just because they're not security focused, meaning that sometimes we don't put security or cybersecurity on the top forefront of our minds. But as we can see, even with the events of the AWRL, we have a problem in the amateur radio community when it comes to cybersecurity. We're not doing enough. I've tried my best here over this past several months to bring awareness. I've went to the BPQ32 groups and I've told people, hey, don't use Debian 8. It's been out of security updates for 6 years. Hey, don't disable your Windows updates so your machine doesn't restart. You probably need Windows updates. I've tried to do all these things and it kind of just falls on deaf ears. All the while I'm sitting on this 0-day vulnerability. So it's been a little frustrating trying to go back and forth with these users the past few months. Let's talk about the vulnerability. So this vulnerability will allow anybody with access, of course, to telnet or your HTTP port of a BPQ instance running on Windows to leverage that for remote code execution. I did a write-up of all of this if you all want to follow along, if you're interested in the technical details. On my blog, I'll put the link. This is a write-up detailing several vulnerabilities I found before the remote code execution. Basically, the way BPQ32 handles buffers and data login forms, things like that, and how they can be leveraged for code execution. So if you're interested in all the grimy details, you can pull this up and look through it and possibly use it to, try to exploit your own application and make sure that it's not vulnerable to the same thing. The big bug that I'm talking about today is going to be called a structured error handler overflow paired with remote code execution. Let me go ahead and bring up the VMs we're going to be using with our proof of concept I'm talking about today. So I have two different virtual machines. I have a Windows virtual machine who's going to be basically your client. This is what you would be running BPQ32 as. And I also have a Kali Linux virtual machine, and this is my attacking machine, okay? So, and just to show you guys, this is a freshly imaged system as of yesterday. It is running the most recent version of Windows. It's not having to keep back on Windows Vista or anything crazy. This is Windows 11 with the most recent updates possible. Not only that, but all the security settings are left basically the exact same as if you started. They have this exclamation mark, I think because OneDrive isn't set up, but that's it. Otherwise, my virus and threat protection, real-time protection, tamper protection, all of this is on. The only thing that's off is OneDrive, so that's one thing I didn't set up. But this is how Windows comes out of the box. The only thing that I went and did was install BPQ32 and put a small configuration file. And so let me show you what this configuration file looks like. This is a example of one that would be vulnerable just because it has this telnet or HTTP port. So what we're doing here is we're opening actually two ports. It's called we're calling it telnet, and the driver's telnet, but in reality we have a telnet port on 8010 and we have an HTTP port on 8012. Other than that, everything's basically left as the default config. I wanted to keep this as simple and straightforward as possible. The only thing I did change, let's see, I enabled the BBS application, but I'm going to go ahead and start BPQ32. And so I'm just going to double click on it, and it's running. So this is just an example of a Windows computer running BPQ32. This is now vulnerable because it is also exposed publicly. And to demonstrate that, imagine if I were to navigate. So this is the BPQ32 HTTP instance that we just saw. It's running. I'm pulling it from this Kali Linux server. And as you can see, also, I'm able to telnet into it just as you would typically, right? So this is just showing you that the telnet is accessible or the HTTP is accessible. Those are the only two rules that have to happen for this machine to be compromised. And most people hosting BPQ32 are typically exposing one of those, whether they know it or not. And I want to go ahead and also say that if you're not advertising your IP address, that is not a security feature. That is like obscurity, right? Right now, the entire internet's worth of IP addresses can be scanned in approximately 6 minutes. So you just not giving your IP address out is it's not secure. Like, people can still find that. I've developed myself a application that scans for specific BPQ32 network language, basically during a port scan. It is not secret. Your IP is not secret. Everybody knows it. It's, like I said, 6 minutes is all it takes to scan the entire internet. So it doesn't really matter if you've never put the IP online. If you've exposed one of these ports, somebody can go through with the port scanner and they can see that you're running a BPQ32 instance on either one of those ports. So how does this exploit work? This is called a SEH or a structured exception handler overflow. So typically, whenever Windows runs into a problem with an application, the way it's handled is a structured error handler. And the developer of the application will do something to try to handle an error in application, right? And it forms a chain. It's called a SEH chain. So it tries the first thing, and it says it's a try catch statement if you're into coding. It'll try the first error handling procedure, and if that doesn't work, it'll go on to the next thing in the chain, and it'll keep on going until eventually it's out of programmer labeled error handling, and it goes into the default Windows one, which is typically to terminate the program. Now, one thing that you might have is a structured error handling overflow. And this is when even the error handler itself has been overflowed. So it triggers the error handler because the application runs into an issue because it's being overflowed, some buffer. But the error handler itself is overflowed. And what we can do with that is direct the next error handler in the chain to a special gadget called a pop return somewhere in the program. What this pop return assembly code does is move the instruction pointer for the next instruction some 8 bytes forward or backwards, however you look at it, on the instruction pointer chain in assembly, and points it to another address that we control with our buffer. Inside that address, we put the jump code instruction to jump over our error handling into the buffer that contains shellcode that we want executed. That's a lot of words. If you guys are not into this computer memory management stuff, that's okay. You don't have to understand it. I'm going to still show you how it executes and what it looks like. So I'm going to go ahead and show you the proof of concept that I've already created here, that is we're going to execute to leverage to get remote code execution on this Windows computer. So here we just have a Python script at the very top. This is the IP address of the machine we're going to be attacking, 133. This is the Windows machine right here. You can see the IP address 133. The port is the port. In this case, this proof of concept was developed for the telnet. So that's the telnet server. And the size is going to be the total amount of bytes that we're going to send. So this buffer is just a shell code that was generated using an application in Kali Linux called MSF Venom. You can see the command that I used here. Basically, you can run this command to generate shellcode. The only difference is I am telling it to only use alphanumerical caricatures. That is because once we send this over to the telnet port, it's only expecting login information, right? So if I send any type of weird bytes, there is a procedure in there, maybe in the logging, that filters those out. So the shellcode had to be generated using alphanumeric characters. After this buffer, I basically build the payload. The payload consists of the buffer, which is the shellcode itself. We have something called a NOP sled. So if you don't know what a NOP is, it's this 90 is the byte in assembly, but it is basically a instruction in assembly that says do nothing. We use them in exploits because you can chain a bunch of them together to create something called a NOP sled, so that if program execution hits anywhere in this sled, it basically slides on down to the next instruction. It's basically hope we're going to do nothing all the way up until we do something. The jump code, this is the code that I just talked about that we're going to get to with our pop return. This jump code is basically just jumping some amount of bytes over the current exception into the NOP sled 2. The current exception I've overwritten with an address right here, and this is called little, I don't want to say little Indian, is that what it's? Anyways, it's a format, it's backwards. This address is actually 42.13.85.E3. This is a static address that relates to the pop return gadget that I found within the BPQ32 executable. That's important because a lot of times you have to rely on a pop return gadget that is outside of the native executable, which makes the exploit OS dependent. And this is not the case. Since this gadget exists within the BPQ32 executable, we can basically live off the land, is what we say. And this makes it OS independent, so theoretically it should work on any version of Windows. So we write that as the current exception. This is the code. This is the address we want to jump to, which is the pop return, which moves the EI pointer to point to our jump code instruction. Our jump code executes and it runs into NOP sled 2. And this is a repeating pattern. You'll see the payload right here is multiplied by 21. This is repeated 21 times. So once it jumps into NOP sled 2, what really happens is we slide on over into the buffer, into the very beginning again. And then our buffer executes, and we have remote code execution. The rest of the exploits is just the network code to actually just send the exploit. So there's not much else to it here. If I execute this while BPQ32 is running, and I'm listening for a shell, then I will gain remote code execution. I will gain a shell with full access basically into this system. So here we have our little BPQ32 instance. It's running, it's doing its thing just like BPQ32 instances do. This would be a server. This would be your client that you're running on your network and you're providing BPQ to people. It would be exposed. The HTTP port or telnet would need to be exposed over the internet for this to happen. Typically they are. And then here's your attacker side. Here's me, a bad actor. I found that, oh, this BPQ32 instance is exposed. It has a telnet you can log into. What can I do with that? All I have to do now is just send the Python payload or the exploit. So I'm going to first start listening for a reverse shell. So I'm going to do netcat, and we're going to do listen, Berberos, and for the port, we're going to use 8080. If you don't know where I got that, when I first generated this shell, I used port 8080 to tell the shellcode basically where I'm going to be listening at or where to call back from. So here, all I'm doing is I've started a netcat listener. I'm just listening for connections on port 8080 on this attacking machine. And now I will go ahead and run my exploit. See how fast that was? All I did, I sent the exploit, and then look over here on our netcat listener. What is this? This is a shell into that Windows computer. So let's type in dir. Let's just make this bigger because none of the other stuff matters anymore. This is me controlling this other computer. I can go into its C drive, I can list its contents. I can go into the users folder. Let's see, list its contents. Let's go into that KN4 MKB folder, and let's go to their desktop. This is me having a command prompt into their computer. This means I can download anything that I want using commands like certutil. I can execute anything I want just by putting the name of the exe. I can delete things. I can create things. I have control under, let's see, the privileges. I can type in who am I? And you'll see that I am running under the user KN4MKB. That's because I started BPQ32 as the Windows user. Let's take a look back over at Windows to see what's going on. Over here, it appears nothing's really happened to the user of this application. It looks like everything's still running, as planned, but as an attacker, I'm in the system now, and I'm able to do anything that I want. I could even, if I wanted to shut it down, obviously I could type in, was it shutdown? Shutdown /s. I think that's the command. Let's go look at, you're about to be signed out. Yeah, so like I can do anything I want from this. So you see the problem. All right, so I hope you guys enjoyed this this little video. Again, I'm not trying to get anybody's computer hacked. I am trying to bring awareness to a very real problem in the amateur radio community, and that is a lack of focus on the cybersecurity aspect of the services that we host and the applications that we run. One thing that we don't think about all the time is, and even like, I'm going to put this up here, I'm not going to tell you who it is, but it goes back to we don't think about the fact that the context in which we run applications, just because they're intended to do a specific thing, doesn't mean that they'll be confined to that thing forever. If someone's able to exploit that application, they can use the privileges of that application to do anything within that context. And so that's one thing I want to bring awareness to, because obviously that's something we need to talk about. But also, I'm going to iterate again. Do not expose insecure services over the internet. Even if it's HTTP or it's telnet, there are things that you can do to make those protocols more secure. Telnet, I've already documented how you can run this over an SSH tunnel. That way at least the connection is encrypted, your passwords aren't sent in clear text. If you don't do that, if you don't use SSH, anybody between you and the person or HTTP, if you ever log into a service, they can see that in clear text. Any person or any device within the thousands of devices it takes sometimes to reach from point A to point B, they can be leveraged to use that username and password to control your radio systems and control your computer. In the amateur radio space, when we link computers to our radios in the internet like this, we open our radios up to be very abused. People can use these systems to make our radios transmit all kinds of things. They can lock on the push to talk for hours on end if they would like, if there's no safety features. They can use them to basically you can lose your license because a lack of responsibility when it comes to keeping your services and your radio secure. So I want to bring awareness to this, and so this isn't a trying to like get a bunch of people messed up. This is a very real problem in the amateur radio community. This is one piece of software that I took a look at. I run a lot of different software on my computer. I have not dug into every one with the amount of depth that I've dug into BPQ32. There could very well be many services in your amateur radio world, if you were exposing them publicly, that could have the same issues that you see here. I just haven't dug into them personally. In the amateur radio space, we typically don't pay people or penetration testers to try to exploit software like I've done today. So there's a lot of vulnerabilities floating around out there. The best thing that you can do as a user is use the best practices to help secure yourself. And if you would use best practices, for example, on BBQ, that would leave you secure against the things that I've shown you today. You wouldn't even be using telnet or HTTP. Even if you lock them behind a reverse proxy, the system itself should not have direct internet access. So even if someone gained a shell on this system, they shouldn't be able to connect back over the internet. This should all be behind a reverse proxy that is masking that behind a HTTPS reverse proxy server somewhere, and that would stop that problem from happening too. There also shouldn't be ports coming back out of this system on port 8080 or any kind of weird port on the firewall, right? There's no reason for a BBQ32 or a Windows server running to need to access port 8080 outside really anywhere. So it just comes to blocking things that should not have access in the first place, or not allowing services that don't need to be accessed privileges anyways. The entire internet doesn't need to access your BBQ32 telnet instance. It doesn't need to access your the entire internet does not need to access your HTTP instances. You need to limit those by IP on your firewall and only give designated users out there access to your system. So if you want people to have a node-to-node connection, that IP should be whitelisted in your firewall. Not everybody needs that, right? So it all comes down basically to using those best practices as users. We can protect ourselves, but also being aware more as application developers. The things that could have been fixed on the application side today. This executable was compiled without safe structured error handling. 64-bit applications by default are. This one is not. Another thing is address space layout randomization, ASLR. This executable, to my knowledge, was not compiled with that enabled. And that's why I was able to use that static address for the pop-pop return gadget to always get the execution to work correctly. If this was compiled with ASLR, or if it was compiled with safe structured error handling, both of those things either one of those things would have stopped this exploit from being possible. And so on the application developer side, we have to be aware of best practices and also be aware of the buffer sizes that we use. I think most modern programming languages basically prevent you from using unsafe buffers. So it's a lot of this like older software that is programmed in older programming languages that still use unsafe buffers. But there are a lot of different things that we can do to try to mitigate this automatically. But we just need to be more aware as users as well. Anyways, I'll stop rambling. Thank you guys so much for watching. I hope this was entertaining or educational in some way. And do not use this to go out and try to exploit any devices. This is it has been responsibly disclosed. Hopefully people are aware at this point, and hopefully people have done the mitigations. And that's basically it. 73 to you, and I hope you have a good weekend.